I am Anil Kumar. Welcome to my series on inverse trigonometric functions. Now, this is a very difficult topic which is least understood at high school level. Many times you get questions related to this topic in competitive exams. My series will help all the students to understand the basic concept. I'm going to begin from the very beginning. In my video, you'll find a visual presentation which will show you what exactly inverse trigonometric functions are. Why do we restrict their domain or range? And how do we work with them? And then we will have about 8 to 10 questions on each topic to understand all the related concepts. Enjoy the video. In this video, we'll discuss about arc cosine x, the inverse of cosine function. As you can see, we have drawn the cosine function wave, which has a maximum at x equals to 0 and a minimum at x equals to pi, maximum being 1, minimum being 0. However, the wave is periodic and therefore it fails the horizontal line test. As you can see, the horizontal line cuts through at more than one point, and therefore its inverse will not be a function. To ensure that the inverse is a function, we will have to restrict the domain of the cosine function. We can restrict the domain from 0 to pi. In that case, the portion of wave which we have is always decreasing, as you can see, and it passes the horizontal line test. So with this restriction of domain from 0 to pi for the cosine function, we have an inverse arc cosine x, which is also a function, and this will map with the complete range. So for cos, the range is from -1 to 1 on the restriction of the domain from 0 to pi. The inverse will now have a domain from -1 to 1 and range will be from 0 to pi. You get the idea. And the cosine function inverse will look like as shown here. So what you notice here, that the function which was always decreasing in the restricted domain has now been inverse by reflecting on the line y equals to x, and you see how the x and y coordinate points change. So now we have -1 pi on the left hand top coming down to 1, 0. So the inverse has a domain from -1 to 1 and the range from 0 to pi. So I hope you understand this concept. How do we restrict the cosine function to ensure that its inverse, arc cosine x, is also a function? In the earlier video, we had seen how do we restrict the sine function, and now we know about the cos inverse x or arc cosine x. Let us take some examples based on inverse of cosine function, and in this set we are also going to include sine inverse functions, combine them together and see some interesting examples. I hope you enjoyed the visual presentation on inverse of cosine function. As shown in the presentation, we restricted the domain of cosine function from 0 to pi. Now, the inverse is also a function. Just as we did with the sine function, we have restricted domain of cosine function. However, you will notice that the restriction on sine function was from minus pi by 2 to plus pi by 2, and for cosine it is from 0 to pi. That is to say, when we are looking into the cosine function, in that case, we are looking into the domain which is from 0 to pi. Now let's look into the details of how to work with inverse of cosine functions. Well, the restrictions on the cosine function y equals to cos of x is that the domain is from 0 to pi and the range is from minus 1 to 1. That is to say that we are looking for the cosine function which is always decreasing in the domain. It passes the horizontal line test and its inverse is a function which is seen here in the red graph. So, the inverse of the cosine function decreases from 1 to 0. So the inverse function y equals to cos inverse x, which is also written as arc cos x, has a domain from minus 1 to 1 and the range from 0 to pi. So basically, the domain and range swaps when we are talking about the inverse functions. Perfect? That's the easy way to remember. And also remember that for cosine function, we are actually looking for quadrant 1 and 2 so that its inverse is defined. Now let's look into the mapping of coordinate values. So we have a column of cos exact values, and corresponding to those, we have another row which matches with each column value for the inverse. So basically, cos of 0 is 1, but cos inverse, when we do, the x and y values swap, as you can see there, and that is followed all over. So we have this table just to show you that for every angle, when we are talking about the quadrant 1 and 2, in that case, the cos values which are at 0, 1, inverse will be 1, 0. If it is pi by 6 square root 3 over 2, the inverse will be square root 3 over 2 pi by 6. When you are trying to find cosine of any angle, you get a value x. Inverse, we get the radian answer, the angle, principal angle between quadrant 1 and quadrant 2. Does that make sense? Correct? Have a good look at this table and understand that always the cosine function is decreasing when we are looking at it. It is from it is defined in quadrant 1 and 2 as mentioned. Now let us take some examples and understand how do we evaluate the inverse function. If I have cos inverse of square root 2 over 2, what is that equal to? So the question for you is find principal value of A, cos inverse of square root 2 over 2, B is cos inverse of minus half, and C is cos inverse of 2 pi by 6. Whenever you are dealing with such questions, it is important to keep these special triangles handy. The very first one is the pi by 4, pi by 2, pi by 4 triangle in which the sides are 1, 1, hypotenuse being square root 2. The other one is pi by 3, pi by 6, and pi by 2 triangle where the sides are 1, square root 3, and 2. They will provide you with the exact values and you can relate the angles with the values. Let's look into part A, which is cos inverse of square root 2 over 2. To find the value, we are actually looking for the angle which will give the cos value, right? So we are saying this is equal to y. Basically, it means cos of y should be equal to square root 2 over 2, right? That's what it means. So, if you see, whenever square root 2 is involved, pi by 4 will be involved, and the answer is pi by 4, correct? So, this value is pi by 4, correct? And as you can see, this value is within our domain. So, the angle which we are always looking for is in quadrant 1 or in quadrant 2. Since it is a positive value, angle has to be in quadrant 1, right? So remember this, that we are always looking for a solution either in quadrant 1 or in quadrant 2 whenever we want to evaluate cos inverse of anything. Perfect? So there we go. We got the first answer as pi by 4. You can actually pause the video and write down the answers for this. Now when we say minus half, so looking into this, cos being minus half, angle being pi by 3. So we know the angle is pi by 3. However, it is cos inverse of negative half. So the negative value is in quadrant 2. How do we get this solution? Can you tell me? So it is kind of like this. The related acute angle is pi by 3, right? So what is the principal angle which will give you cos inverse of minus half? Well, clearly the principal angle is pi minus pi by 3. You get the idea, right? So the answer is pi minus pi by 3, which gives you 3 minus 1 as 2 pi by 3. Is that clear? That is how you're going to find the solution. Now let's look into the next one, which is cos inverse of 2 pi by 6. Now, what is 2 pi by 6? Well, 2 pi by 6 is greater than 1. As we know, the domain should be between minus 1 and plus 1. It cannot be greater than 1, and therefore this value does not exist. Does make sense to you? So I hope this concept is clear. Here is the solution to all the three questions. So as I said, cos inverse of square root 2 over 2 is pi by 4. Cos inverse of minus half is pi minus pi by 3, which is 2 pi by 3. Perfect. When we say cos inverse of minus half, we are saying that cos of y is, let us say this value is y. In that case, what is y equals to? Cos of y, correct? Cos of y is minus half. Minus half means you are in this quadrant. And for that, the value is right there. The related acute angle being pi by 3, and therefore the principal angle is pi minus pi by 3. I'm laying stress on this since I've seen many students making a mistake right here. And this is very interesting. As you know, 2 pi by 6 is greater than 1, and therefore the solution does not exist. So I hope this point is absolutely clear. Let's move forward and take the next question now. Question number 2. Find domain of the given function. So we have cos inverse of x plus 3 and cos inverse of x squared. I'd like you to pause the video at this stage and then find the domain of these functions. Well, here is your hint. For both cos inverse and sine inverse, the domain is between minus 1 and 1. So that helps us to figure out, right, both included. So we have to find domain of cos inverse of x plus 3. It really means that x plus 3 should be within which boundaries? Minus 1 to plus 1. We can find what values can x take. Take away 3 from both the sides. So we have minus 1 minus 3. And here we are left with x, and we have 1 minus 3, which gives us minus 4, and the x value is less than minus 2. So the x value should be between minus 4 and minus 2 as shown here. Now let's see how do we find domain of cos inverse of x square. So that means x square has to be greater than equal to minus 1 but less than plus 1. Now square is always positive, right? This is always positive. So we know that it is definitely greater than 0 or it could be equal to 0, right? So that is what we get. Now we can square root all the three. So when you do square root, 0 square root is 0 and square root of x square is what? Absolute value of x, correct? And here we get 1. So basically, absolute value of x should be less than 1, correct? So when we say absolute value of x is less than equal to 1, that becomes the domain of the given function. That means that the value of x is within plus or minus 1, right? So that gives you the value of x between plus 1 and minus 1. Do you see that? So that is how we find the domain of this function. Here is the solution for you. Now, so we know now that for these or for any cosine inverse function to find the domain, we have to solve this inequality within plus or minus 1 to get our answer. I hope this strategy is absolutely clear. Now let's talk about equivalent inverse functions. This property is very helpful in solving many equations related to inverse trigonometric functions. Let's have a closer look at this angle A itself. What is sine A? Sine A is opposite side A over the hypotenuse C, correct? So we see that sine of A is basically equal to A over C, correct? And what is cos of A? Well, cos of A is equal to B over C. What does that indicate? Well, if you write in the inverse terms, from here we are trying to say what? And from here, what are we trying to say? We are saying what A is. A is sine inverse of A over C, and A is also cos inverse of B over C. But the angle is same. That means both should be same. You get the idea. So what I'm trying to say here is that angle A is sine inverse of A over C, and it is also equal to cos inverse of B over C, and therefore sine inverse of A over C is always equal to cos inverse of B over C. Not only that, we can look into tan inverse of A over B, cosecant square inverse of C over A, secant inverse of C over B, and cotangent inverse of B over A. All are representing angle A. You get the idea. So to find the angle A, what can you do? Well, to find the angle A, we could find sine inverse of A over C, right? Or we could use cosine function. So that is what we are trying to say, cos inverse of B over C, and so on. So that means that all these inverse trigonometric functions are related. If we make a triangle, then we can see very clearly the relation between them. And all these values shown here are the values for A. You see that? And that is how you could write one trigonometric inverse as a different one, right? And these are called equivalent inverse functions. Have a good look at it. That is going to help us in solving many difficult questions. Here is question number 3. I'd like you to pause the video, read the question, answer, and then look into my suggestions. If arc cos k equals to alpha, where k is between 0 to 1 and alpha in radians, find in terms of alpha the first two positive values of x satisfying the equation cos x equals to k. So we are saying that if arc cos k equals to alpha, and we are given that k is between 0 and 1, right? So k is between 0 to 1 means we are looking at quadrant 1. Whenever we talk about inverse function, let me just show you here. Whenever we're talking about cos inverse function, we are looking into this region, correct? From 0 to pi, right? So we're looking from 0 to pi. Now, cos is positive in quadrant 1, but negative in quadrant 1. 2. Since k is always positive, we're looking for quadrant 1, in which the graph of cosine function is like this. Do you see that? So it goes from 1 to 0. So it is decreasing, going from 1 to 0, as shown here, right? Okay. Now it says r cos k equals to alpha, where k is from 0 to 1, alpha is in radians. Find in terms of alpha the first two positive values of x satisfying the equation cos x equals to k. So if I have cos x equals to k, here we can write what? We can write cos alpha equals to k from this equation, right? Comparing the two, we definitely get x equals to alpha. We need to write x in terms of alpha, so that becomes the first principal angle. Now, what could be the second principal angle? This is what we have to define. So, we got one solution, which is alpha. Now, as you know the cast rule, cos is positive in quadrant 1 and in quadrant 4, and therefore the other solution has to be here. Since we are interested in finding the principal angle will be 2 pi minus alpha. You get the idea. So the other angle for x will be 2 pi minus alpha. So these are the two values of x in terms of alpha which will satisfy our condition. Is that clear to you? Perfect. Here is the solution for the same. Arc cosecant k equals to alpha, where k is between 0 to 1. So, arc cosecant k equals to alpha implies that k is equals to cos alpha. Or, we know alpha is in quadrant 1 or in quadrant 4 since k is positive, right? So, we have possible solutions in 1 and in quadrant 4. Cos x equals to k. That means we are now comparing cos x equals to k with cos x equals to alpha. And that is true only if x is equal to alpha, right? So we get one solution. This is in quadrant 1. The other one will be 2 pi minus alpha, which will be in quadrant 4. So these are the two solutions for the given condition. Perfect? Here is question number 4 for you. We will look into the range and the relation with the cosine. Given arc cos x equals to beta, where beta is between 0 to pi by 2, find the range of x. And part B is find expression for sine beta in terms of x. So if the angle is between 0 to pi by 2, then what is the range of x? Well, it is not negative, it is from 0 to 1, right? So only values which it can take is what? So range will be from, well, the condition given here is not including, and therefore, so we'll say from 0 to 1, correct? Not including. Part B is find expression for sine beta in terms of x. So look here, we're given arc cos x equals to beta. That basically means that x is equals to cos beta, correct? So if x is equal to cos beta, we can make our triangle. So we are coming back to the triangle which relates all inverse relations, correct? So we are saying cos beta, so let's call this angle as beta. Cos beta is x, that means adjacent side is x, hypotenuse is 1. So what is going to be the opposite side in this right angle triangle? Well, clearly it is going to be 1 minus x squared square root. And now you can write down what sine beta is. And therefore, we have sine beta equals to opposite over hypotenuse, and that gives us the value square root of 1 minus x squared over 1, right? Which is square root of 1 minus x squared. It has to be positive since we are talking about the quadrant 1. Is that clear to you? That is how we are going to solve this question. So if you look at this from the angle I've shown you just now, making a triangle, it becomes extremely simple to solve. Here is our solution. We'll also provide you with an alternate solution. So once again, arc cos x is equals to beta, that means x is cos beta, where beta is being between 0 and pi by 2, that is in quadrant 1. Range is 0 to 1. Those are the values which cos beta will take, right? Now, to find sine beta, we could also use the trigonometric relation, Pythagorean theorem. Cos beta is x. So what is sine beta? So you know, cos square beta plus sine square beta is 1. So we can rearrange and write down that sine beta is plus minus square root of 1 minus cos square beta. So we use Pythagorean theorem here. Now, since we are talking about quadrant 1, it has to be positive, right? So cos beta will be positive. Cos beta is x. Substituting x for cos beta, we get 1 minus x square square root for sine beta, and therefore we get our solution exactly what we did, making a triangle. Well, in this case, beta angle is shown here. Do you see that? So beta is for b shown here. Cos beta is x, so the adjacent side being x here and the hypotenuse being 1. The opposite side calculated square root 1 minus x squared also helps us to find the solution. Perfect. Okay, now let's take example 5. Evaluate expressions. Given xyz belongs to the closed interval of minus 1 and 1, such that cos inverse x plus cos inverse y plus cos inverse z is equal to 0. Find the value of x plus 2y plus 3z. You can pause the video and then answer this question. So let me rewrite cos inverse x plus cos inverse y plus cos inverse z is equal to 0. Now, since we are given that xyz is between minus 1 and 1, we know that cos inverse of x should be between what? It has to be between 0 and pi, right? That is how the inverse function is defined. Now, this is true for cos inverse of y and cos inverse of z also, right? So all of them are also between 0 and pi. Is that clear to you? So the minimum value is 0, and all are positive values. We need sum of these three as 0. How can we get it? Well, it is only possible if cos inverse of x is 0, cos inverse of y is also 0, and cos inverse of z is also 0. Now that implies that x is equal to what? Well, if cos inverse of x is 0, then the value of x has to be 1, right? Because this means x is equal to cos of 0, and cos of 0 is 1. Similarly, we can get the value for y and z to be 1. Is that clear? Perfect. Now we can find what is x plus 2y plus 3z. So we can now add this up and get the solutions. X plus 2y plus 3z is equal to what? X is 1, y is also 1, so 2 times 1 plus 3 equals to 6. So the answer is 6. Clear? Here is the solution in details for you. You can pause the video, look at the solution, understand each and every step, and then move on to the next question. Clear? Example 6. Transformation of inverse function. Given g of x is b f of ax, where f of x is b cos inverse, here's a typing error, f of x is cos inverse of x, right? G of x is vertically stretched by a factor of b and horizontally compressed by a factor of a, right? So that's a typing error. X belongs to minus 1 and 1, a and b are greater than 0. So both a and b are positive. Describe the transformation of g of x. So clearly, we have f of x, let me rewrite. F of x is given to us as cos inverse of x, correct? And g of x is vertically stretched by a factor of b, horizontally compressed by a factor of 1 over a. So two parts to this is you need to describe the transformations, and you need to write the expression for the minimum and the maximum coordinate points for the transform function g of x. Clear? You can pause the video and write down the answer. Now, before getting into this detail, I would like to show you the presentation. So have a good look at how the graph of cosine and cosine inverse changes by changing value of b and a. And after that, we'll continue with the solution. Here is a visual to understand the vertical stretch and the horizontal compression of sinusoidal function. We are taking the function b arc cos ax. So I am varying one of the parameters. Can you tell me which one is being changed at present? It is being horizontally stretched and now horizontally compressed. Perfect. And therefore, it is the a value which is being changed. If a is greater than 1, in that case, there is horizontal compression by a factor of 1 over a. If a is less than 1, then there is horizontal stretch. At the moment, a is less than 1 and you see horizontal stretch. Perfect. Now let me change the other parameter, which is b. b is the vertical stretch factor. As you can see, the y value gets multiplied. 0 remains at 0. So the minimum for b arc cos ax is still 0. However, the maximum, which was pi for cos x, is now b times because it is vertically stretched by a factor of b. So if b is greater than 1, it is higher, and if b is less than 1, it is lower than cos x. So you see how the vertical stretch and horizontal compression affect both the function and its inverse. So I hope this concept is absolutely clear. And now you can explain the solution for our example number 6 by a factor of 1 over a, right? So graph is always decreasing, as you have seen in the presentation also. The maximum value is now multiplied by b, so it becomes b times pi. This happens at minus 1 over a, and the minimum value remains at 0, which is at 1 over a, correct? So we can now write down the coordinate points as minimum being at 1 over a, 0 being the value, and maximum at minus 1 over a is b pi. Is that clear to you? So I hope that presentation really helps. So that is our answer, which we just shared with you. Here is question number 7. You need to evaluate these expressions. Use the concept of periodicity to find the answer. A. Cos inverse of cos 2, cos inverse of cos 4 pi by 3, and C is cos inverse of cos 25 pi by 6. You can pause the video and answer the question. Remember, the definition of cos inverse is when we have restricted our domain from 0 to pi, correct? So the value of 2 is within 0 to pi. Pi is 3.14, it is less than that, and therefore we can say that cos inverse of cos of 2 is basically equal to 2. So any value, basically cos inverse of cos of theta is equal to theta, provided theta is between 0 and pi, correct? So that is the condition. Now since 2 is within that, it will be 2. Now 4 pi by 3 is out of range. Do you see that? So what to do in this case? Cos inverse of cos 4 pi by 3. We are not talking about here. This is 4 pi by 3, correct? 3 pi by 3 is pi. 4 pi by 3 is pi by 3 more. So we are out of this interval. We can write this angle as what? Well, we could write this as cos inverse of cos of what? 2 pi minus this angle, correct? And how much is that? That is 2 pi by 3. That gives you 4 pi by 3, right? 2 pi minus 2 pi by 3 is 4 pi by 3. So that gives you same as 4 pi by 3, right? Now cos is a periodic function, and therefore it should be cos inverse of cos of minus 2 pi by 3. Correct? Now cos is also an even function, right? Since it is an even function, I could now write this as 2 pi by 3. So I could write this as cos inverse of, well, that was cos 2 pi by 3, right? Let me rewrite this. Since cos is an even function, we can write this as cos inverse of cos 2 pi by 3, correct? Now 2 pi by 3 is within the interval, and therefore we can write this answer as 2 pi by 3. So as you can see, we do get a solution in spite of the fact that the angle given here was out of our domain. Since cos is a periodic function, we used this strategy of periodicity and got the answer. Perfect. I'd like you to attempt the next one yourself. 25 pi by 6 means that this time the angle will be somewhere here after a couple of rounds. Do you see that? So figure this out and get the solution. So for your reference, here is the solution of all the three questions. So for cos inverse of cos 2, we get 2. For cos inverse of cos 4 pi by 3, we need to rewrite this as 2 pi minus 2 pi by 3. Since cos is periodic, it becomes cos of minus 2 pi by 3. And since it is even, it is cos of 2 pi by 3. So a couple of properties, right? So here we see period of 2 pi for cosine, right? And here we see even function. So that is how you could evaluate inverse functions. You get the idea. Here's the last one. I hope you must have got this answer. 25 pi by 6 means 2 rounds 4 pi plus pi by 6. So when you go, this is 2 pi, right? 4 pi and then pi by 6. That is where you were when you say 25 pi by 6. But you'll end up in quadrant 1 where the related acute angle is pi by 6, and therefore cos inverse of cos pi by 6 will be pi by 6, and that is how we are going to get this solution. I hope it is absolutely clear. Now here is a very important property of inverse functions. I'd like you to closely look at it and understand our proof. Question is to prove that sine inverse x plus cos inverse x is pi by 2 for all x between minus 1 and plus 1. Now, most important thing here is to look into the domain of the function, right? When I say cos inverse x equals to theta, in that case, theta is between minus pi by 2 to pi by 2. That is how we define inverse of sine function, correct? So let's begin from here. Let sine inverse of x be equals to theta. In that case, theta is between minus pi by 2 to plus pi by 2. Now, if I multiply by negative sign, then what happens? Then it becomes minus pi by 2. Theta is greater than or equal to minus pi by 2 and less than pi by 2, correct? Minus theta. So what has happened here? Look here carefully. So we had minus pi by 2 is less than theta is less than pi by 2. Now when I multiply by negative number, both these signs, they interchange. Do you see that? And we get pi by 2 here and minus pi by 2 here. So that is what we have written here. Is this point clear to you? I've seen many students do not understand this step, and therefore I've made it absolutely clear. So from here to this place is what we've done here. So now we have minus theta, which is greater than or equal to minus pi by 2, but less than or equal to pi by 2. Let us add pi by 2 to all, right? So we are doing plus pi by 2. To get to the next level. So we get 0, and then which is less than or equal to pi by 2 minus theta, which is less than or equal to pi. So we are trying to say that pi by 2 minus theta is between 0 and pi. That is the condition for cos inverse. Perfect. Let's continue. with our solution. Sine inverse x is equals to theta means x is sine theta. Now co-function identity. Sine theta can be written as cos of pi by 2 minus theta, correct? So we are saying that in any triangle, if this is theta, right angle triangle, and that angle will be pi by 2 minus theta. So cos of theta is same as, sine of theta is same as cos of pi by 2 minus theta. So that is the x value. Now writing it as an inverse function, cos inverse of x is what? Pi by 2 minus theta. So we get the value of cos inverse of x. Rearrange. So when you rearrange, bringing theta to this side, we get cos inverse of x plus theta as pi by 2. But what is theta? Well, theta is, as you know, sine inverse. So we replace this theta with sine inverse and we get the result, which is cos inverse of x plus sine inverse of x is pi by 2. You get the idea. So rearrange and get your solution. Extremely important identity. Remember, sine inverse x plus cos inverse x is pi by 2. Perfect. Two more questions to go. Here is question number 9. Relate inverse function. Given that is not proved, it is given that y equals to cos inverse x for all x between minus 1 and plus 1 and y between 0 and 1. Express sine inverse x in terms of y. So how will you express sine inverse of x in terms of y? One of the methods shown here is, when I say sine inverse of x in terms of y, so we have to write this as a function of y, right? Let's begin with what is given to us, which is y is equals to cos inverse of x. So if I rearrange, I get x is cos y. Now, cos y can be written as sine pi by 2 minus y using co-function identity. Correct? Now, x is sine, I'll rewrite this first. X is equals to sine of pi by 2 minus y. So that means sine inverse of x is what? Well, sine inverse of x is pi by 2 minus y. Is that clear to you? So we have written sine inverse of x in terms of y. Perfect. So that is how we can do it. Last question for you, question number 10. I'd like you to pause the video, answer this particular question. Evaluate composite expression. Evaluate the following: cos of cot inverse sine of tan inverse 1. We are going to use our special triangles to evaluate. Okay. You can pause the video, answer the question, and then look into my suggestions. So let me rewrite this. Cos of, so there are a lot of functions. Cot inverse of sine of tan inverse of 1. Let's close all the brackets. Okay. So we'll start from inside out. So first, what is tan inverse of 1? Pi by 4, right? So let's write down that. So we get this as equal to cos of cot inverse of sine of pi by 4. Now what is sine pi by 4? 1 by square root 2, right? So sine pi by 4 is 1 by square root 2. This is cot. So cot inverse of this. Now let us say, let's look into this triangle now. cot inverse of 1 over square root 2. So if you look into this triangle, cot inverse of 1 over square root 2 will be what? Let it be equal to, let us say, alpha. That means cot of alpha is equals to 1 over square root 2. So cot of alpha means, let's say this is alpha for us, is 1 over square root 2. That means this is 1 and that is square root 2. Is that clear to you? Do you understand? Cot of alpha is 1 over square root 2. Now once we have this, we want to find what is cos of this, right? So what is cos of alpha, right? So we're saying cot inverse of this is alpha, so that is cos of alpha. And looking into this triangle, what is cos of alpha? Let's find the hypotenuse. Hypotenuse will be what? Let's calculate. It will be 2 square root 2 square plus 1 square root, which is square root 3. So cos of alpha is 1 over square root 3. Does it make sense? That is how we are going to solve this particular question. Here is the solution in details. So as I explained, we'll start with inside out. Tan inverse of 1 is pi by 4. Sin pi by 4 is 1 over square root 2. So when it gets to cot of 1 over square root 2, then what happens? We could actually also get into this particular triangle. So we say cot is 1 over, so that means 1 over square root 2. So that is our angle alpha. And then we can make the next triangle, and looking into this triangle, we can find what is cos inverse of this, right? So we have from here, cos inverse is 1 over square root 3, right? So cos of cos inverse will be 1 over square root 3. You could do like this. Or you could go with the triangle as I explained to you. Is that clear to you? So that is how we can actually solve this particular question. So with that, we come to an end of our basic information on working with inverse of cosine functions. Here is the summary. As we have seen, the cos function is restricted from 0 to pi. Now its inverse is possible, with the domain inverse being from -1 to +1 and the range being from 0 to pi. Domain and range swaps. So it's a decreasing function with minimum value of 0 at x equals to 1 and maximum of pi at x equals to -1. We also found that this identity, sum of sine inverse of x and cos inverse of x is pi by 2, holds. With that, we end our session.
I hope you enjoyed this video. We'll now take up many examples where all will be involved. We'll have functions within functions and some difficult questions from previous test papers. Keep watching my series and I hope that helps. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.